You're listening to Worth Electronics What's Up radio podcast, where each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and our very own Worth Electronic technical specialists. We're going to shine a light on our topics like energy harvesting, wireless power transfer, EMI issues, and so much more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Worth Electronics What's Up podcast. Picture this. You're driving down the road. It's night, it's cold and raining and on the verge of snowing. And all of a sudden, your vehicle gives up and you end up needing to be towed in the middle of the night. The reason? A simple damaged passive component. Now, any more passive components that are only AEC Q200 tested are not enough for the use in automotive applications. Many more tests are needed for qualification for a good design and high quality component. And everybody knows that without electronics, our vehicles will not operate. Well, we can avoid this nightmare altogether with a few little design tips using passive components that are adequate enough. Today's podcast comes from our recent webinar with our very own Laurent Focal, creator of the Ask Laurent videos at Worth Electronic. In this presentation, Laurent covers which qualifications you need to fulfill a component, what materials are best for filtering EMI noise, where you should be using these passive components, and then ending with design support from Worth Electronic. Enjoy today's Worth Electronic What's Up podcast with our presentation, EMC Passive Components for Automotive Applications.
First of all, you will ask yourself why you need some special automotive parts and you just not can use any other parts. Well, the answer is quite easy. For automotive, you will need some special requirements, not only just documentation like PPAP and some EMDS entries for what is contained in a component. You need that the whole chain of these products have been manufactured according to the certification IATF 6949. And last but not least, a component must fulfill this ASQ 200 qualification. And what this means, I will go by piece. So for Worth Electronic automotive standard products, we are using in a world production chain, not anymore TS 6949. We use this International Automotive Task Force 6949 qualification, which is something like a harmonized standard of the ISO 9001. It means all the production steps and all the production facilities have been passed all this certification. This International Material Data System, IMDS, started in the early 2000. I remember it was 2004 when I was making the first entry for Chibit ferrites. It is something which starts from the Japanese automotive industry to be sure that the components are lead-free. And today, over 120,000 suppliers are already using this database, and we can, of course, put all our materials included in these parts, and you can access this database and you can see what is containing almost on atomic level. The Automotive Electronic Council, they are making for the ACQ 200 related to the passive components. They have also 100 for the active components. They define some specific tests which the component must fulfill. Also the numbers, how many pieces you have to test and how you should test according to which standards. And last but not least, the PPAP production part approval process. They are containing some warrants for released component, and it's a kind of contract between the supplier and the customer that you will supply the components according to all this qualification and data sheet. And of course, it's also vice versa. The customer will confirm that he will use the component for a specific automotive product. Well, this PPAP, according to this ACQ, it contains the 5 different levels, but Worth Electronic, we can supply only 2 different levels, level 1 and level 3. What is the big difference between level 1 and level 3? First of all, by level 1, it's quite easy, I would say, fulfilled just production sheet warrant, the data sheet, and some rows reach documentation, which is quite very easy to fulfill. The level 3, that is a little bit more deeper documentation. You will receive not only just the FMEAs and flowchart and the final results. It's a big, I would say, a big documentation which you will get for one simple component, which including all the tests which have been done and what was the results of course of the test, and if this component fulfill or not fulfill. And just for imagination, what means this PSV document, part submission warrant? It's kind of one sheet documentation, but many customers forget that when you receive this part submission warrant, it is signed and stamped from Virtual Electronic, but it's not valid until you're not signed by yourself and send us back a copy. So this is very important that this, I would say this contract is valid only if you sign the document and send it back. If you just take it and put it ad acta, it doesn't mean that it will be accepted by, in case of you want to claim something. So it's very important when you get this PSV document, sign it by the authorized person and send it back to Virtual Electronic. By the PPAP level 3, was a little bit more, I would say, clever. And when you buy a component like here, an example, a PDA in a value of 10 microhenry, you will get the whole documentation of PPAP level 3 for the whole series. So it means if you will use for another project or for the same device a 4.7 or 100 microhenry inductance, you don't need again the whole documentation. You will get, as soon you get one from this product family, one component, you have the whole documentation for all of them. So this is quite very favorable, that you will have less paperwork and less headache, and you have all the results and everything. And you can see here, this is an example again from this PDA. This is from different size made, the high temperature exposure, temperature cycling, mechanical shock, ESD, solderability, all these tests according many times to military standards. And if it's not military standard, then it's kind of JEDEC standard. And this is what is possible to fulfill. What is not included, and we are still testing, is like by solderability. We make at Virtual Electronic 5-time reflow process. Even the ASIC 200 doesn't require this 5-time reflow process. We are have some experience, more like 30 years we built components, and we find out if the component withstand the 5-time reflow process, then we did design a product which is quite very reliable and robust and will not fail in case you are soldering the PCB and you have to rework it or resolder it, or you have to change some components, and if you make 2 or 3 times reflow, it may be broke some components. That's the reason why we qualify our products for a 5-time reflow process, to be sure that they will withstand all these shocks of temperature, high temperature soldering. The IMDS was starting quite early, like I told, in the early 2000s, and it was actually the guys who was looking for to be lead-free components in the cars, and today more like 35 OEMs already is inside, and a lot of supplier. If you look at Virtual Electronic components, like in my example, the PDA, you will see that. I just realized that this is the screenshot of German. Apologize for that. Like copper means copper. Copper wire, just a simple copper wire contains something like a phosphor. And when you read phosphor, you say, oh my God, what is this? This is not impossible, because it's not RoHS and REACH compliant. Yes, it is, because phosphor with the copper wire, it's atomic level bond, and you cannot take it out. So you cannot melt it, or cannot. Okay, if you make a disintegration of the wire, you can have also the phosphor, but I don't think so that anybody of you want to try to disintegrate the inductors. So, but you can see on the atomic level, you will get everything, of course, also in English or even in Chinese. If you switch on the IMDS language, you will get in the right language translated. The IATF 6949 started in early October 2017, and the most automotive OEMs already following this qualification standard. Of course, also our production line have been requalified to this new IATF 6949. The ASIC 200, it is for the passive components, but they have also some subdivision like 006, which means measurement methods for resettable fuses. Of course, it cannot be applied, this test method, for the inductor, because the inductor is not a resettable fuse. I would say the inductor is quite a logical fuse. If it's work, it's one, perfect. If you overshot him with too much current, it's burning away, and this is zero, it means it doesn't work anymore. But you can see on the right side, you have this different qualification, and you will get this paper, which a number of lot have been tested, how many pieces, and of course, if it's fulfilled or not fulfilled, or pass the test or not. For the temperature grades, we have 4 different temperature grades, starting by 85 degrees 85 degrees Celsius ambient temperature. This is grade 3, up to 150 degrees Celsius, which is the high temperature exposure, grade 0. This is what components can withstand. The 125 is quite very popular, but we have grade 2, which is 105 degrees Celsius. This is because the component itself, he can withstand much more, but the packaging, the enclosure, like the plastic housing or something, they are not able to reach 125, but at 105 degrees Celsius, it is still very stable and there's no damage at all. And you can use it in this ambient temperature. You stay on data sheet. Always you will see the logo on this ASIQ grade on the data sheet. If we talk about temperature, let's talk about what means in fact this temperature, the component. If you read the data sheet, you will see something like rated current, like 22.5 amp. This is for a high current inductor. I chose an example from a high current inductor. Means if you apply to this inductor 22.5 amp through this wire, he will generate a self-heating of 50 Kelvin. If you look now in a page, the operating temperature says minus 55 degrees Celsius up to 155 degrees Celsius. It means if you apply the maximum current with a self-heating generated, you can use it in an ambient temperature maximum 100 degrees Celsius. If you have an ambient temperature above 100 degrees Celsius, like 125 degrees Celsius ambient, and you want to use the maximum current, you will overheat it. It will be running out of the specification. So above 100 degrees Celsius, like at 125 degrees Celsius, you must derate the current. You cannot apply any more than 22.5. In this case, you can apply maximum something like, well, at 125 degrees Celsius above, I will say less than 10 amps or something, 10, 11 amps, because you have to derate the current for sure, else you will overheat the current, the component. If you look for the next declaration, storage temperature, minus 20 degree plus 40 degree. Many of you will think this is a paradoxon because operating temperature minus 55 plus 150 and store only 20, minus 20 to plus 40, this is not possible. Yes, it is because we deliver these components in tape and reel packaged. So if you want to store this component on the Antarctic at minus 50 degree or minus 55 degree, I would highly recommend to heat them up this warehouse to minus 20, because else this plastic, this tape and reel, this glue of this tape, it is not guaranteed that will work. It will break. Even if you will store that in Nevada, where it could be more like 40 degrees Celsius warm. I remember last it was the maximum record ever recorded, something above 50 degrees Celsius. You have to install air conditioning and cool down to minus 40 degrees if you want to assemble these components. After you take these components out of the tape and reel and solder it to the PCB, it's starting the operating temperature. I don't care if you will power it with current or not, you can store it from minus 55 to 150 degrees Celsius. But I don't think you will find worker for a warehouse by 150 degrees Celsius. So definitely pay attention about the declaration, because we deliver that in tape and reel packaging. That's the reason why the storage should be in this parameter. Ambient temperature, if you have less than 100 degrees Celsius, it's also not recommended to overheat the component to reach the 150 degrees Celsius, because you're running out of the maximum temperature. You can read that also from the data sheet. We have a curve which is say at which current, which temperature rise you will achieve. This is something which many design engineers forget to double check, and then they realize very late that, oh, my efficiency is less than 80%. Which is not good. So we have some new components additional. I will not go to all these different parts, but if you use ferrites, at ferrites, most of the ferrites for EMI and EMC situation, it will be used a nickel zinc component. If you look on your VGA, HDMI cable or USB cable or the laptop power cable, you will see sometimes molded ferrite, which is a nickel zinc ferrite. Nickel zinc have a very nice bandwidth, especially in high frequency, but we find out in lower frequency it is not so effective, so you will need another material. And this other material is not nickel zinc anymore, is magnesium zinc. Magnesium zinc, less than 10 megahertz area, it is more effective like nickel zinc, and above 10 megahertz is 1-to-1 to nickel zinc ferrite. So that's the reason why we did develop this magnesium zinc. And for less than 1 megahertz frequency, around, I would say down to kilohertz, you can use the manganesic zinc ferrites. And if you want to cover very wide band, low frequency and high frequency, you will need this nanocrystalline core, which is not a sinterate ferrite. The nickel zinc cores are from the temperature range, minus 55 plus 150 degree. They are quite easy and robust. They are high temperature sinterate. It's no coating need because himself is not conductive. So even if you scratch or broke and you put your probes into the grain, you will not measure any resistance, except if you use dynamometer, because his resistance is not conductive. It's like ceramic mostly. If you compare that with the magnesium zinc, the magnesium zinc has only just one issue. It has only 150, instead of 150, only 140 degrees Celsius operating temperature. His Curie temperature is a little bit lower like nickel zinc. That's the reason why we keep distance to don't reach the Curie temperature. So until 140 degree, it's not a problem. It's also not conductive, doesn't need to be coated. It's quite used. And if you see here this graph, we compare the same size, the same fixture, the same calibration, magnesium zinc. I always have to pay attention. Magnesium zinc and nickel zinc core, and you can see above 10-20 megahertz they are absolutely identical, but in a lower frequency this magnesium zinc, it is better. It has a more possibility to filter, so you can get more damping, and this is the 50 ohm system. If you use that in power supply where it's a system impedance not 50 ohm, it is normally 10-20 maximum or even less, it is much more effective. For lower frequency, you will need manganesic zinc, and manganese zinc need to be coated. Even if it's a sinterate ferrite material, if it's a naked form and you have on your table, you have a nickel zinc and manganesic zinc. If you don't have a 100,000 euro magnetic analyzer, you will not distinguish which is which one. But maybe if you take your multimeter and you take the probe and scratch on the surface on the manganesic zinc, you will see by the multimeter, kilo ohms, or even if you are very close and broke the grains, you can see even hundreds of ohm of conductivity. So manganesic zinc is conductive if you compare with nickel zinc. And that's the reason why we coat them to don't make any shorts. And it's a very high temperature layer coating. It's not only color, it's also have some isolation layer. And this is very useful for if you use that in higher voltage application or so on. Will not make any short circuits. By the nanocrystalline cores, well, nanocrystalline cores are different from a sintered material. Nanocrystalline core is not only coated, they are in a plastic enclosure. Nanocrystalline core is not a sintered material. It is some special iron oxide which is melted to be fluid, and they will be shock cooled down, and during this shock cooling they will build some crystals, and these crystals are in a nano size, and actually you build a very, very thin tape, and you roll this tape in a ring form, and this is very, very easy to crack and very sensitive to pressure. That's the reason we put that in a very good enclosure. This is a plastic housing, and because of the plastic housing, it is only -40 plus 125 degree operating, but it's the most stable ferrite core. So if you compare with the sintered magnesium zinc, nickel zinc, they have a drifting in the temperature. In a low temperature, the permeability is dropping, and in the high temperature, the permeability is going up. But the nanocrystalline cores are very, very stable in the temperature because it's a not sintered material, and he has an extremely high permeability. I would say 100 to 1,000 times higher, like nickel zinc or magnesium zinc, permeability up to 100,000. And because of that, have an excellent AL value. It means to reach the same inductance value, you don't need to turn 10 turns to reach something like 10 microhenry. Only by one single turn, you are hundreds of microhenry already reached, and you can cover because you don't make turns. Turns makes winding capacity, and this winding capacity make that his resonant point going down. And because you go only just one time through the ferrite core, you have a straight wire with the ferrite on it. It makes an inductor, and because he doesn't have a winding capacity covering a large bandwidth of noises, then you can use that for onboard charging, or you can use for wall boxes, whatever. And the new product that we did qualify now for automotive is this Snap-on ferrite Cartec. Many people use and know the StarTech ferrites, which is for industrial application. The Cartec is special qualification for automotive. And this is the last chance when you already built the car and you want to sell it or you want to ship it to the customer, and you find out, oh my God, we have some D-class amplifier which makes some noise, which was unattended, and what to do now? I cannot say names of company because we have an NDA for them, but you can put some Snap-on ferrites on these cables, and they are very useful. Even you don't need to disconnect or cut the connector and resolder the connector or crimp it the connector. You just put the Snap-on ferrite, and we have also some holder for that if you want to fix it to the body of the car, or just wrap it with tape to make no knocking noise when the car is driving. It's very, very useful, like a last chance if you are not want to requalify the whole EMC test and you don't want to redesign because it will take time and maybe another chip will be not available again on the market and so on. It's not the nicest method, but this is a good method, and I know many companies, they are already happy to use them. What happened actually in this ferrite core when we are applying this EMI noise? Actually, we have in the physics a law which say energy cannot be lost. Energy is always must be transformed in a different form. Actually, when you talk about EMI noise, you have a H field vector and an electric field vector, 90 degrees to each other. If you cut one of those vectors, you have no transmission. You're EMC safe. But what happened with this energy? Actually, the eddy current losses, this magnetizing, demagnetized losing, which is happening, the border domain changing into this small particle in a ferrite, generate heat. Honestly, I hope you will never build a device when you put a ferrite, you will make the ferrite hot, because you have a safety problem, not EMI problem. But when you make immunity tests by cars, you can test sometimes up to 400 volts per meter. And in this case, if you put the ferrite on a certain place, the ferrite can run really hot. sometimes it can happen. I had these situations a few times in the lab, and I did not believe it that the ferrite can run so hot because of his losses. But finally, he was passing the EMC test. Should be not the right solution all the time, but it's possible to. That's actually the explanation what is making the ferrite. If you want to solve the problem on the PCB level, is much more clever, and you can use the very low-cost cheap components, which is also cheap components. We call them cheap bit ferrites automotive, CBA. Size of 0402 is not so nice to solder by hand during the design. I prefer 0805, and going up to 1812, you can reach very high current up to 8 to 10 amps sometimes even then, and you have a wide band solution, you have a high current solution, you have a high speed solution for high speed signal where you can have ferrites which until 50 megahertz has very, very low impedance, and they start to be very impedant and very high, hundreds of megahertz, and you can still use for high-speed signals. How it looks, the ferrite bit inside. This is a computed tomography, this time not on my bones, on ferrite bit 0603. Excuse me. You can see the two electrodes on the top and bottom, and the inside layer, it's a pure silver layer, and the zinc or the electrodes, a pure zinc with a nickel layer to make a good contact to the silver. If you have kind of inrush current or low dump test, and you find out that the ferrite bit is blowing away, because the standard ferrites can happen. If you exceed the maximum current of the ferrite beads, standard ferrite beads, it can very easier happen that you are blowing them away. If you want to avoid that overshot of this inrush current, you should use the MPSA. This is a multi-layer power suppression bead for automotive, which we did develop, and they are a totally different manufacturing process. We use different machines where we can also quantify and qualify how much can be this short time pulse through this component. So normally we say up to 20 times higher like the nominal current, but you will find that in the data sheet, or if you go to our RedExpert website, it's a free software where you can even calculate how often you can admit this overshot pulse, this inrush current, and if you are reaching more like 100,000 of pulses, you can be safe, you can sleep well. If your calculation already in the RedExpert say maybe 10, 20 times, then it's your decision which customer you want to make angry, or how often your device should be switched on, and how often or how long should be the lifetime for this device. Maybe you can shorten the warranty in this case. But definitely this MPSA are in a different way made, and they are much more robust for inrush current, and we can specify that in the data sheet, and we know that if we say more like 100,000, you will be happy, it will never broke. If you're afraid about inrush current and you see, okay, 10, 20 times is for me not good enough, then the only one decision what you can take a wired component. If you use a wired component instead of multi-layer, you may not face this problem. For differential mode noise, you can use cheap bit ferrites. For common mode noise, you have to use common mode noise suppressor. For automotive, of course, in 0805, we have this new product now. You can see it's a bifilar winding with a very, very low leakage. That's the reason why you can use up to USB 3.0. It is for infotainment, for data lines. For CAN bus, maybe is not so strong enough because his inductivity doesn't reach this 51 microhenry, but in some cases is also good for CAN bus if you have facing the high frequency issues. But it's a common mode suppressor for quite very nice bandwidth. The dinosauria of filtering, I will say it was the rod core inductor in automotive. Still today, after more like 30 years, you will find them in many, many applications. Every electrical motor, DC motor, at least they have two pieces of them. If it's a step motor, even more. I counted last time in the electrical seat, it was 64 pieces in one electrical seat mounted in a very a valuable brand, which had also massage function and heating and cooling and whatever. It was nice to see that this rod core is still very often used. Of course, this is a little bit difficult because a through-hole component is difficult to mount it. Because of this reason, we developed also this plateau SMD mountable, so pick and place from tape and reel. You can improve your production, speed up the production. A nice example from a customer here, he was driving a motor with a DC-DC converter, and he was facing some conductor emission problem. We saw this rod core inductor, which is actually have a magnetic open field, and we tried to fix it without making too much redesign. So only one redesign, what we see, say, okay, you have a double-side PCB, please float the empty spaces with ground and change this inductor to the shielded version, because rod core inductor have an infinite air gap. He can eliminate his magnetic field to infinite, and that's the reason why a shielded inductor, it's more close magnetic field. And you go to the EMC lab and make the test, and you can see this is the bottom line of the instrument. This is the noise floor of the instrument. He is just a little bit above the noise floor, and from here he reached that noise. That was, I would say, really a lucky punch, not every day Sunday. So he was reaching that very happy. The EMC guy was also fascinated. He doesn't believe it that something like that can be happen, only just put some components like that. So it's a big benefit if you use for storage always a shielded inductor. And to prove that, I can show you here, if you cut an unshielded version, like this is a PD2A, which is for automotive unshielded version. It's a bobbin core with some wire in it, and you put that vertical to the PCB. This is the position. So actually it's an antenna. So he will make the magnetic field as soon you charge him. It will pump up this magnetic field to the infinite. Now, if you have the same bobbin core, like the left-hand inductor, the PDA, and you put now a shielding ring around him, you can see that this strong magnetic field, which is closest possible to the wire, he turned back using the shielding. Air is very bad magnetic conductive, and with this shielding, you turn back the bigger, stronger magnetic field into the core, and you will have some leak because you have a gap on the top and on the bottom. And we need this gap because this gap defines the saturation point of the inductor. If you would have no gap at all, he will saturate quite very fast. So the energy is always stored in the air gap. So that's the reason why we are playing with these air gaps on the inductor to make it not too noisy, because you have some escape of the magnetic field, but to keep the saturation point quite very late. So this is the good thing about the shielded inductance. And now we took this DC-DC converters by a switching frequency of 2 MHz, 1 amp output, and we start to measure some EMI peaks on conductor emission. And for testing reason, we just take a soldering iron, desolder this unshielded inductor, and take the same value of 10 microhenry with a shielded version on the same footprint, and try to not touch anything, no wires, anything on the setup, to be 100% the same setup for remeasure it. Just compare it, the unshielded version in the same DC-DC converter, conductor emission, with the shielded version. And as soon we did make the measurement for the shielded version, we realized that we have a drop of 19 dBm difference in comparison with the unshielded version. I highly recommend to always use a shielded version for storage inductance. It will be paid back, especially when you go into the EMC chamber for radiated emission. Again, the same setup, just taking a soldering iron and change on the same DC-DC converter, the inductor to be shielded. It's paid back definitely in the EMC chamber. Invest this shielding, this little bit more money for the inductor, in this case for the shielded version, but it will be definitely paid back. The PDA, it's one of the most used in this case for automotive application, can be up to 1 millihenry from small size, 7.3 by 7.3 up to 12 by 12 in different age. And this is with a plastic base. If you take the PD series, the difference is only just the base, the same core, everything is almost same, just the base is different. By the PDA is plastic base, by the PD is a metal base. Using this metal base, the difference is by the wire to connection to the electrode, so the termination. The termination by the PD series, by metal base, we use soldering. Because we use soldering as connection, we can use bifilar, trifilar wire, or multi-wire. This kind of soldering, it's no problem for them. By the PDA series, where we use the plastic base, we don't use soldering, we use welding. And using the welding, we can use only one single wire. So we cannot put twins or trifilar wire because it's not possible to solder them. So this is the big difference. That's the reason why the PDA goes only up to 1 millihenry, and the PD goes up to 2.2 millihenry, and because we can use different thin twisted wire and so on. That's only one difference. Footpin compatible, temperature, everything same, core losses, everything same, because it's the same core. The PD2A, this is the unshielded version. This is good for filtering. If you want to use something for filtering, it's perfect to use an unshielded version. No need for a filter to use a shielded version. If you still use a shielded version for filter, the only one advantage is that to reach the same inductance value with a shielded version, you don't need to put so much wire because you have a bigger AL value, you have more magnetic material, and the DC resistance will be better. But no EMI reason. You will not be facing a filter inductor with shielded or unshielded version better. I would say, just in case if you're close to resonant point. Yes, because the unshielded version have more turns, more capacity of winding capacity, and if you use the shielded version, because less turns of the wire, you have a higher frequency reaching, and the resonant point is more in higher frequency. This is the only reason. If you still use for DC-DC converter a specific size of 7.8 by 7.8, and you find out in the EMC chamber, oh my God, I have an EMC problem, maybe you did choose the right size, because for 7.8 by 5 millimeter H, we have also the unshielded shielded version. So we have a shielding for the PD2SA, footprint compatible completely. Of course, we cannot reach every high values because we take with the shielding some space from the winding, so we can go up to 220 microhenry. But I remember the customer when he did use this 7.8 by 7.8 inductor, and he was facing the EMC issue, and we offer him to use the shielded version. He was very happy to pass the EMC test without redesigning. This is how it looks inside. If you make a X-ray on this component, you can see this very nice winding. This is the sign of machinery winding and not some hand wiring, low-cost manufacturing. It's very robust and very, very effective, of course. Now, if you want to use the high-tech inductor, which can reach of the smallest volume, the highest inductance value, and the highest current, you have to choose Maya. This is, I would say, in the passive components, the most intelligent inductor. Okay, he doesn't have artificial intelligence because he cannot decide which color should be the screen, but it is excellent because have very low core losses. It is very temperature stable because it's not a sintered. It is a iron molded, so we take some iron oxide. First, we make the winding, it's like an air choke, and we put this powder together with the air choke, and we press them together, and then it's completely molded. We have no air gap at all. Works perfectly, cannot be reached at very high inductance value like millihenry, but even in high temperature range, we have some of those which can go up to 150 degrees Celsius. And this is how we manufacture them. You can see here on the left picture, it's the animation of component, and then you can see the X-ray and the CT of the winding, and then you see on the right picture the mechanical cut inside, what is how it looks out inside of this core. So I told you it's no air gap inside. Maybe few of you will say, oh, for a small 3 by 3 millimeter inductor, it means instant saturation if I put this 1 amp current. Not correctly, because we still have a distributed air gap. So by the Maya design, it is like we use a very specific powder where we have the air gap distributed into the core material. Of course, you can saturate this well, and it will have a linear saturation. Doesn't have this knee saturation like the PDs, because the air gap is very defined. Here, because we have the whole entire mass of this magnetic compound, it has a linear saturation. The high power inductor for a shielded version is actually a rod core inductor. Rod core inductor put on the plastic base, fix it by using welding again with a flat wire. Some of those are existing with round wire, and to make it EMI efficient, we put him a shielding around him. Maybe I should show you the next picture. You can understand better what I'm talking about. This, you can see the magnesic the magnesic core inside. Sometimes it's also possible to have an iron core, and this is also this ferrite shielding, which define with this plastic enclosure very specific air gap to not saturate, because you have the airbag inside, so you have very, very small leakage of magnetic field on the bottom, which is very close to the ground, to the PCB, and that's the reason why it's excellent for EMI issues. And this is full automated manufacturing, is no problem. This glue is here only just to fix during the mechanical cut, to see what is inside, how it looks inside this material. Very high current, up to 81 amps, and very low DC resistance down to 0.6 milliohm. This high current inductance for, I don't know, maybe for some very, very high current DC-DC converter, where you will face up to 150 degrees Celsius. It is also in bigger size available. It's very robust as well. It is on 3-point fixing, but one leg here, it is not connected to anything. This is just mechanical fixing. You don't need to put that to ground or to whatever. It is no electrical function. If you still use the through-hole technology rod core inductor, and you find out, oh my God, my rod core inductor make EMI noise, we can offer that with a shielding. So this has a rod core inductor inside, and we put that together into the packaging of magnetic shielding. It can be up to 25 amps and extremely low DC resistance, but also the inductance doesn't go up to higher, like 0.5 micron, because it's very short, because we have to put inside of this small enclosure. Sometimes for processor which need very, very high current and extremely high frequency, it is suitable. If you want to use some molded inductor, which can be also going with extremely low DC resistance, is very similar to the Maya, but it has a bigger volume a little bit. This is the extremely high current molded inductor. It can reach also extremely high amps, up to 50, 60 amps. And actually, it is used for the D-class amplifier. This is a very good inductor for the output of the speaker, to make a good filtering for a D-class amplifier, where you want to drive a nice, I would say, bass. When you use a car, you need a good bass. And for me, all the time when I buy a car, first after the sound check of the engine, I make the bass check. How good is the bass? This bass is need to feel it in your Plymouth when it's running. In this case, for this D-scale amplifier, you will need that kind of inductors. For other application, this is a high current inductor with a flat wire, quite very performant. We have also in the performance series, which can reach with a very, very small DC resistance. This is the standard one, and then you have also some with a cube, which is a high current suppression performance inductance, which has better coplanarity. The best thing what you can do, this is also from the iron inside. It's more performant for saturation point, and this we call them performance components. As soon you make anything by keyless entry or RF in your car, or you want to use some RF, you will need some multi-layer chip inductor, and then it's also possible to get them down by tolerances 0.3 nanohenry with the polarization on the input on the beginning of the wires, very crucial sometime by matching antenna for high gigahertz frequency or for Bluetooth devices. When you want to fix something, PCBs with some spacer, mostly use hand manufacturing because they are bulk in a package or whatever. We developed one pick and place SMD solderable, so you can put it to the reflow oven, make a pick and place machinery, and you can assemble that by pick and place. Of course, here to apply your ASIC Q200 will be quite very difficult because this is not electronic component. Some customer even use it for grounding. It is also possible. This is without the thread inside. If you want, we have also some with thread with different sizes. It's a M3 thread and pick and place with a small captain. I pull up the captain, making the picture, but has a small captain that can be assembled by the vacuum assembling machine. Yeah, some other nice mechanical components is this copper beryllium finger contacts, which can be used for grounding. Or one of the customer, he was very clever. He had a problem by the RF antenna to connect this small clip, and during the manufacturing the process, the guys who did make all that, they complained the finger it's hurt. Other one complaining that the quality control that it was destroyed the connector for these clips. It's quite difficult to make that automatization on this case, and he did use his finger contact. You put on the PCB, and when you apply this PCB into the enclosure, into the housing, it was the hot wire from the SMR connector, and he was connecting this SMR connector by this copper beryllium gold-plated finger contact, and it was excellent for RF as well, and he doesn't have problem, and more cheaper to realize. Another customer had also some sandwich of many PCBs to each other using connectors, and these connectors was the weak point by the vibration test, and sometimes they have some failure because it was a connector not correctly assembled to each other. They must open the device and put by hand again the connector in the right place, and after we present him this contact fingers, which is again tape and reel, and you can assemble it by SMD and solder by reflow. He had the idea to change it, and he changed the connector. On one PCB he had just golden plated contacts, and on the side is finger contact, and when he assembled together this to each other, it was contacted only by the pressure of the spring, and it was perfect working. No more issue in the vibration. Even higher vibration was no problem to him, and of course some money saving. It was a good opportunity to save some money. Okay, space is maybe a problem sometimes because you don't have this very small pitch, but it works. Design kits available for all these different components. You can ask my colleagues from the sales, and they will be very happy to offer to you these design kits. Also rack, if you have a small lab or you make some designs, you can ask for this different module 14 and 16. They're special for automotive manufacturer. If you want to have an empty one, also possible to put your screwdriver or whatever. We saw that one customer did order 4 pieces and only just one fulfill it with our parts. The rest he would use for himself or using his tooling on that to be very nice in the lab. If you have an EMC lab, it's also possible to have this rack. Also possible to have one stage, 2 stage, or completely 3 stage. I would say for the automotive components, it will be enough to have this kind of rack because there are not so many like in the industrial components. But if you're driving an EMC lab, you will have not only automotive maybe to qualify. More information about filtering or LT-Spice simulation, we have this new LT-Spice book. We have also new trilogy and also other books for different capacitors, for magic modules and so on, connectors. Please ask my colleagues as well for get a copy or order it by DigiKey. They have also on stock. And if you're designing anything in your country and your mass production is shifted to another continent, don't be afraid. We have almost different country own sales office with our own salespeople and FIEs. Everything what is red covered, that is served directly from Würth Electronic, the yellow one by distribution. When you see the black dots, they are the factories. One of the dots is here in South Dakota in Watertown, where Amelia is located. In Mexico, we have also in America another facility in Irapuato. In Europe, even in Germany, we have inductor. We make a Rodcon inductor fully automated. We are able to manufacture them cheaper like in China, which is quite nice to know that we can do that, of course, by full automation, but it is running a quite big volume, something like 30 billion per month. It can be possible to still do it in Europe and also in Bulgaria, in Romania, Hungary, in Italy. We have facilities and we make some connectors there or snap-on ferrites and so on. But of course, the major components are made in China and Taiwan or even in Korea.
This podcast was taken from a recent Würth Electronic webinar. To view the materials and replay the webinar on demand, visit www.we-online.com/webinars or click the link attached in this podcast. You can learn more about passive components and find our complete automotive portfolio by visiting Würth Electronic online. Look for this episode in our profile or click the link available in this podcast. You're listening to Würth Electronics What's Up radio podcast, and each week we are seeing what's up in the world of electronics and PCB design. We'll be checking in with leading industry experts and Würth Electronic technical specialists who are going to shine a light on our topics like energy harvesting, wireless power transfer, EMI issues, and more. Tune in to get technical design tips and applications during your commute, at your desk, or wherever you might be with Würth Electronics What's Up podcast.